Hey everybody, it's the Deephaven community team here, June week one. So
All right, so we have merged our Groovy support for Iceberg static tables, and I'm going to just walk through, redo some of the stuff that we did a month or two ago, but with the final um, API and interfaces. So the idea basically is we'll create an adapter that will reach out and talk to an Iceberg um, warehouse catalog, and we can start querying it for tables, namespaces, and then actually go and retrieve data. So I'm going to walk through all of that today. First, let's bring in some useful imports. And then I'm running this locally, so I'm using S3 as the backend storage for the Parquet files, and then REST, a REST compatible catalog. And these are all running locally, so get some pretty good speed. But all right, we've got a working adapter. There's a couple of different layers of working into getting the getting data out of the catalog, but this one is just this namespace is just as a simple string list. Will show the namespaces available on the catalog. I can drill into the namespace sales and list all the tables in there, and then I can for in an individual table, I can actually peek in and look at the individual snapshots. Now, this is slightly messy because it's actually returning an list of objects that are being translated to string. So a little nicer view would be a table. So of course we implemented that. For this, the namespaces of the catalog as a table, we can see we've got 3 namespaces, and then we actually include the namespace object if you want to pull that out and use it directly. A list of tables inside that namespace, and then inside the single table, sales multi, here's the different snapshots. So that's just metadata about tables. That's actually show how you would reach out and get some data out of the tables. So we have this S3 instructions object. If you followed some of the Parquet stuff that our team's been working on, we can reach out and read pretty efficiently data out of Parquet from S3. So this is kind of just our little instructions object that lets our underlying engine know how to talk to the Parquet files out there. So I'm just going to create one. It'll simulate connecting to an S3 region on the eastern with some basic credentials. Bring in the import with that, with the import, and then a local endpoint override just so I can use my local instance instead of reaching out to the cloud. So I'm going to do a simple Iceberg instructions object. This is something we'll include with all of our calls to the table read calls, and this is just a really simple way of allowing the S3 instructions object to be passed, but also more detailed and customizable parameters like column renaming and column elimination. So I'm going to create an Iceberg instructions, and then let's do some fun stuff. All right, I'm going to go ahead and expand this. And the first table we're going to read will be from the sample namespace, the all types table. This is just a table where we bring in a lot of different data types, Boolean, integers, long. I've used this table just to make sure. Of course, it did that. Just to verify the data types that we support are all in there. And then here's more, that's only 10 fields or 10 rows. So let's do something a little more interesting. Let's bring in one of these sales tables. That's 100,000 rows. You can see it's lightning fast. Scrolling is lightning fast, but these are all being read from the underlying Parquet tables over the S3 interface. And then a demonstration of our partitioning support. We've got the same data but partitioned by year and month. Just for the sake of, okay, well, here's 36,000 rows that are in month 12. The other 100,000 or other 68,000 are here in this other month. Let me just show you the keys. So all I'm trying to demonstrate here is that we support partitioning. Native partitioning as done by Iceberg brings it in, and we can use all of the cool tools you're used to in Deephaven to support partition data for fast access. I'll blaze through these pretty quick, but this is a way to use a custom instruction to do some column renames. We're going to rename region to area, item type to category, pass that custom instructions object into this, and you can see same data, 100,000 rows And we have area and category. And to show off, if you really have a custom definition, table definition you want to expose, in this case, I'm going to keep the renaming, but bring in only 3 of the columns of the table. I can make this call. And we've renamed area, region to area, item type to category, and we're bringing in only those 3 fields. And this is operating on a non-partitioned table, but if we do the same table definition and pass it to a partition data, oops, I ran everything. You'll see that we have the same idea, same number of columns and same number of rows. And again, lightning fast. I'll take just a second to bail on this and just blaze back through this with the Python support. The Python support is in flux right now. So the API and the exact names of the functions may be slightly different, but the capability is going to match what Java has, and that's what I'll show right now. And okay, we're now in the Python world. So very similar. We're going to just bring in this import. Very similar. Create an S3 REST adapter, and then these are slightly more Pythonic names. You're going to list the namespaces, tables, and snapshots just as simple objects as the Python can read and iterate over. Of course, we can make the same calls to bring up namespace as a table, list of tables as a table, and the snapshots of a table as a table. Similarly, we can retrieve data by creating in a Python fashion the S3 instructions and Iceberg instructions specializations. So here's the first data table. This is our all types table just as before. It's got the 10 rows of all the different fields, same data, obviously because it's hosted from the same Iceberg server. And I can bring in the sales tables as well. So here's 100,000 rows, and then here's the partitioned version of that. And just to demonstrate the customization, I don't even, they're not entirely novel. I'm doing the same renaming just in the Pythonic way. And here's area and category. And then with a little help from this dtypes library, I'm going to build a custom table definition. And now I can open this table. There's my restricted column list and the renamed tables, and we've got our 100,000 rows, and it's still lightning fast. And we expect all these to merge and release 35, which we're hoping for maybe by the end of next week. And that's it.
Cool. That iceberg stuff looks really cool. We'll see you again soon for another demo. Cheers.